Hello everybody, my name is Erfigo Smaradheva. Here I will try to explain about the MMSE Estimator. First of all, let me try to introduce the friends. So we will try to explain about the um, minimum mean square error estimator with Alif Alikha, Mufty Putratama, and Daffa Fakhrizaman. We'll try to help you guys to get some knowledge about this material. This is a task from the probability and stochastic process, which conducted by Mr. Ajib Setio Arifin. Hope you guys can enjoy it. Okay, good afternoon to all the viewers. My name is Erfigo Smaradheva with my friends from the Electrical Engineering of uh, Program International batch of 2019. We'll be explaining about the MMSE Estimator. We are from the group 2, so here is the MMSE Estimator. Basically, the MMSE is minimum mean square error, which means it is an estimator which estimate using the minimize of the mean square error, and which is a common measure of the estimated quality of the filtered values of dependent variable. So basically, the MMSE is used by applying the minimum value of probability, and it's usually applied in the Bayesian setting. The term MSA is most specifically refers to the estimation with quadratic loss function. In such cases, the MMSA is given by the posterior mean of the parameter to be estimated. So uh, here I want to try to explain. So basically there are the joint probability of theta and x. Here theta is the data and x is the random variable, the unknown thing that came to an experience. They came to the some sort of cases. So this is the probability. Usually this is in joint. This is called joint probability. What I'm trying to say is the MMSA is applied to estimate the value of the probability in a minimum mean square method. Uh, there are also linear MMSA, which basically the estimator, which the popular choice since they're easy to use, easy to calculate, and very versatile. And so I want to explain the basic steps. So theta here is a random variable based on the data, the theta. And x here is the unknown thing which I already explained before. So here is the so basically theta here is we can describe theta here as a function, like for example gx. So the calculation here will be became this a is estimate expectation. A theta in condition of x is equal to equal to theta. Sorry, the theta with the sign here. So the MMSE estimator of theta is the function here, the theta gx, which minimize the MSA of expectation between the theta, expectation between the theta and the theta with the, maybe I call it theta factor here, theta factor square. Yeah, so basically this is the function gx is expressing the minimum value of this function here. Thus we can explain the theta factor here with the expression like this, and we can insert this into this, so it will express the minimum mean square error method. So let me clear again. And so we can also express this in integral form. Basically the expectation here with the theta with the condition of x, we can express it as an integral such as like this. Just that, oh, I'm sorry. Just theta p theta in condition of x with the variable theta as the main function for the main variable for the integral. So here this expression is basically gx, function gx. So my friend will next explaining about the type about the specification or the form of MSA as an method. There are three forms about the MMSA, which will be explained later.
Okay, my name is Daffa Fakhrizaman, and I will explain about one of MMSE's property called unbiased. Okay, so unbiased estimator. To show this, we can simply compute the bias expectation of the estimation error.
If we substitute the estimator like
And
the way it's calculated,
yes,
condition of expectation
and then we substitute it
x,
with the
and now apply linearity on the expectation.
okay, so I apply linearity to this equation. Okay, so okay,
I
wait.
cannot check the first term.
Okay.
Conditional expectation of x,
Now you can check that
and then
this corresponds to the Yeah, the data.
Again, we have seen in the previous explanation this conditional expectation.
As we can see from the previous explanation,
Expectation
this expectation
variable
we can take from here. So,
corresponds
this corresponds.
so that the result subtract
So the result
theta here equals zero.
when we subtract
So we have
with
shown
this
that
means 0. So this whole thing means unbiased.
as the name
Thank you.
indicates, the MMSE estimator
Okay, hello, my name is Mufty Putratama S from Electrical Engineering. Today I'm gonna tell you a little bit about the MMSE Estimator from the orthogonality principle. Okay, first of all, we write the orthogonality principle first. Like me. Now we write the estimation error first. Sorry for the bad handwriting, so it will be hard laptop to write it. After that, times the function. That's equal to 0. Okay, after that, this is the orthogonality principle. First of all, we will write orthogonality. Okay, so we must prove that this method is fulfills the orthogonality principle that I'm writing here. So what we're gonna do is first we make this equation E bar, and then we write again write the estimation error of the data, and then times the function itself. X, estimation X bar. Okay, so this is the first step. Now we do the second steps. We can simplify by doing this right here. E bar E again. We're gonna put away the hx first. So it's still the same. The estimation error. Okay, wait, some mistakes here. So it's x is inside it, and we put away the function to this function to here. Then okay, this is the expectation error from here to here, and the expectation error from the data is always 0. So whatever the function of hx is, if we multiply by this part, it's always 0. Multiply the 0, any number, it becomes 0. So the answer is 0. So this means that the minimum MMSE estimator is fulfill the orthogonality principle from this function that I made. Okay, and we that's all for me. That proof the MMSE estimator fulfill the orthogonality principle. Thank you.
Okay, hello, my name is Alif Putra Alikha, and today I'm gonna explain about the MMSE estimator is uniquely defined, and it's given by that the X estimator MMSE Y equals to the expectance X in condition of Y. As you can see from the formula that was written here, so we can conclude that the MMSE estimator is conditionally expectance of the given X, known observed value of the measurement. Next is the MMSE estimator is asymptotically unbiased. It converges in distribution to the normal contribution as the formula square root of n times x expectance of x minus x with power of d toward n times 0 I power by 1 times x, where x is Fisher information of x. So the MMSE estimator is asymptotically efficient. Last but not least, it's jointly Gaussian. If the x and y are jointly Gaussian, the MMSE estimator is linear. It has form W, Y plus B for matrix Y and constant B. This can be directly shown using Bayes' theorem as the consequence to find the MMSE estimator. It is sufficient to find the linear MMSE estimator. Okay. Thank you for watching this video. I hope it's useful and make your understanding become more and get more knowledge. And see you next time. It is us from group 2. Thank you. Bye-bye.